Yeah, so I'm back. I think this time you should be able to hear me now again, right? So you can hear something. Yeah, okay. Yes, so next time when you can't hear me, let me know. I will rejoin this course and then it may getting better again. Okay, so this is the uh, blueprint. So it helps the people who do not know the coding, but if they can understand the logic, they can still do something great. So when we finish this, we need to compile it, just like every code. When you finish, you need to compile it, save, and then go back. We still can't see things here because it can only see coin. Okay, yeah, I see. Let me close this. Hope this will getting better. So when I play the game, especially this area, you see now the world is more like, okay, this is more like a file, right? Because the intensity is changing. It's like the file is really shining. Actually, even we go here, we can see the intensity changes. Okay, turn off the. Oh yeah, there's one thing I can do. Just 1 second. Okay, so how things goes here? I just turbo boost my router. Signal should increase. So can you hear me now? Okay, yeah, yeah. I shut down every other equipment and also turbo boost my router. So this is the last thing I can do. Okay, so this is the part. This part is about the Unreal Engine. So you see, at this stage, even we we didn't see any part of the code, right? We didn't see any coding, but we can create this ground, which is capable of playing games. We can add some game logic here and make something more actually. And this is, I mean, not dramatically, but it's still playable, right? It's a playable game. So that's it. Let's go out and talk something new. Now let's talk about something about the real-time rendering. there are some basic concepts I'd like to share with you. Okay, so for real-time rendering, there's some fundamental things we should know. So, first, the real-time rendering is a mix of different solutions because it's so complex. And even in the marketplace, you can buy a lot of graphic cards with different price, right? That's because they have different configuration, different in RAM, different in CUDA cores, the number of CUDA cores, and different in band-wise, right? So why they have this? Because the better graphic cards can handle something great. But even with the best graphic card, you still cannot do the real-time rendering of everything. Okay, so in reality, it is a mix of different solutions. And then we will go through the scalability. And what scalability is? Scalability is more like you should be able to run your game or your film on the different machines or different platform, the mobile or standalone or desktop. Okay, and then we will go through a little bit about the deferred and forward rendering. So what is deferred rendering and what is forward rendering? Later we will see this is what is G-buffer. Actually, G-buffer is the fundamental things for the deferred rendering. And last we will see is the vertex and the pixel shader. We will cover it a little bit. So first, the real-time rendering is a mix of solutions. It's all because the real-time rendering is so complex and it a lot of hardware. Okay, not only the CPU but the GPUs. So you have played games before, right? So for your games, if you choose the highest quality, the picture might look great, but your hardware should be good enough to run the best setting. I mean best configuration, right? And for real-time rendering, we only calculate something at real time, but most of the other things we just pre-calculated, which in computer graphic area we call it the baked, or we reduce the vertices, okay, or reduce the face. They're all done before we play the game, and so we pre-calculate these things and then store it in the machine. So they are not calculated at real time. They're pre-calculated, but they look real. So for every games or every film, there's a balance between these two, and we combine them together to create some dramatic thing. So you just know the real-time rendering is not true. Actually, it means something is calculated at real time, and something is calculated is pre-calculated. So for Unreal 5, because so that's why we introduced Nanite in Real Engine 5, because it can calculate the vertices, the infinite number of vertices at runtime. It's not pre-calculated. It can handle the global illumination at real time. So we don't need to bake a lot of things. We can save some time. And scalability. Scalability means real-time rendering should able to run with change of graphic quality at any time. What does this mean? It means when you play games, there is an option or setting area you can change. I mean, I want the graphic area to be the best, or the medium, the high, the medium, or low quality. Yeah, you can change that. I mean, after changing that, you can still render the thing with different quality, but it can do everything on real time, so people can play the game. It's not like I fix the graphic quality, so for people who have a lower machine, they cannot run it. Then this is not the scalability. Scalability should run at every platform. Okay. So it should be able to run on mobile or different PCs. And here there's R command in Unreal Engine, which can show the FPS and a lot of things. Let me see if I close it. Okay, I'm not closing it, so I will show you some basic part for the R command. So this is the background we just create. We want to see the R command. R command is by the command line, which I press the title key. The title key usually is before the 1. And we call this stat unit. So when I press stat unit, this is R command inside of this game engine. It takes the record about, okay, it's a lot of memory, 1 gigabyte. I mean, for this small area, it takes 1 gigabyte memory. And there's a GPU and game. Game means the things is running on the CPU. Draw means the things between the GPU and the CPU. It also calculates something. And then finally, the GPU is the things working on the GPU. There's a huge lag. I think there's something wrong. It really hurts. Let's wait a little bit until it's getting normal. Okay. Now you see, when you actually doing the code, you should always develop some game. You should always pay attention to the frame rate or GPU rate and the game rate. So you know where the bottleneck is. And so you spend more time on it. Okay. So this is like R command. Actually, we can show something more with R command, but I won't do it now. If we have time, we can go through it later. Let's close it. I hope it won't affect too many things. And also quit this. Yeah. So R command is an example. Like you should be able to check your performance, and when you build a different device, you should know, okay, this device is good in GPU and this device is good in CPU. So I should balance this between these two. Okay. And so to maintain a good performance, combination of these things is scalability. And then there are 2 ways of rendering. One is called the deferred rendering, and the other one is called the forward rendering. Okay, so for deferred rendering, it works for a lot of engine. For example, the Unreal Engine 4 is deferred by default, and also the Unity is default rendering. It can also accept forward rendering, but only on real circumstance. Deferred rendering works best for majority of the content because it gives the best performance. It gives a very stable and best performance but it needs a lot of hardware things. We will see, because it needs something called a G buffer to implement. So it's a lot of memory and require a lot of bandwidth and a lot of GPU cores. Forward rendering is fast, but only works for very simple use. I mean, if the use is complex, it's getting worse. It's getting worse than the deferred rendering. I mean, if we want to have the same result as the deferred rendering, it takes a lot of time. So it only works for the mobile game and some VR game, virtual reality game. Because at this time, we just designed very simple. We design a simple structure, we design some simple environment, and then we can use the forward rendering. Deferred rendering supports a lot of rendering features, like the shadows, different kind of shadow, cascade shadow, shadow field, and a lot of things. But it cannot support the anti-aliasing. So the MSAA, the anti-aliasing, is like it works for forward rendering. What it do is like it renders more pixels than actually needed. So for example, for forward rendering, we only want to render 1 pixel, but if we turn the anti-aliasing on, we render the 4 pixel around it and take the average value. Oh, so network seems I just see some network problem. Can you still hear me? Because the network connection seems not good. Okay, that's great. Yeah, because anti-aliasing is like you calculate the 4 pixels and take the average. So it works for forward rendering because we only increase the 4 size of the memory or the RAM. But for the deferred rendering, we can't, because that's a lot. We will see the next slide, and then we will know why. And most document is a tutorial about deferred rendering. But for this course, the computer graphics, we focus on forward rendering. Because when you know the steps or the procedure of forward rendering, then you will see why we have a deferred rendering. I mean, deferred rendering actually is drawing twice. It's using the forward rendering to draw twice, and the second time is called the deferred rendering because it is deferred. Okay, so if we know the forward rendering, then we will see, okay, those are the drawbacks. Why it only works for mobile and VR, because it can only handle something simple. And then we know why we need the deferred rendering. So for this course, I mean, especially when we talk about the OpenGL in next week, we focus on forward rendering. And so there's a thing called G buffer. G buffer is the fundamental for the default rendering. So for default rendering, it uses a G buffer to store a set of image for each frame. So, for example, if you know something about the rendering, you might heard that there's a software called RenderDoc. RenderDoc is like it's a tool for optimizing the games and the films. So it can check for each frame how many things you have done and how it done in sequence. So from that, you will see for G buffer, actually you store more than 10 pictures. I mean, or more than 10 size of the RAM than just forward rendering. Okay, so in that case, if you still want the anti-aliasing, it means you might need to render 40 times, more than 40 times. That's huge. I mean, that's not only require very big graphic RAM, but also need a lot of GPU cores and need a bandwidth to be very big, huge to handle so many to process this amount of data. So that's why the deferred rendering we cannot have the anti-aliasing. At least at this stage we cannot handle it. So for the G buffer, it contains things like, okay, so it renders the surface normal of each object on the final screen, and it renders the specular part, the specular part of the object on the final screen, and also the diffuse parameters for each things, for each pixel or each object, which can be seen on the final graph, and also the positions. So that's 4. Actually, it renders something more like shadows and a lot of other things. So there might be 10 to 12 pages, 12 more images of the things. And it happens entirely in the background, so we don't know. We don't see it, but we should know it's there. So it's rendered twice. First, it renders the things as the image, as I told, and then it goes back again and combine them together with one more shader, which is a pixel shader, and draw the things. Now we have the pixel and the vertex shader. So the question is, what is shaders? A shader is a small piece of code. It's more like a C code, but slightly different. It's a small piece of code. Those code only works on GPU. They are quite simple, but they can run at the same time for all the vertices or for all the pixels. It means all the pixels doing the same thing, or all the vertex doing the same thing. So it means, okay, so it's good at running on GPU because the GPU have a lot of processor, right? It has a lot of cores. So for example, the RTX 3080 have more than, I think it's more than 8,000 cores. The 3080 Ti, it has more than 10,000 cores, right? So it means because for the vertex shader and the pixel shader, they run on this GPU cores, so they can run at the same time, and they optimize it. These shaders are designed and developed because of the development of the GPU architecture. Okay. And for each pixel or vertex shader, we take the input and give some output. Vertex shader only handles everything about the vertex information, like the position, the normal, the UV coordinate, and so on. And the pixel shader, for OpenGL, it is called a fragment shader. It's basically the same, but slightly different. And for computer graphics, fragment shader is much better than pixel shader because pixel shader seems like it works only one pixel and one pixel is one final thing. But for fragment shader, it means, okay, one pixel can have a lot of fragment shader, and they combine together to have one final pixel. Okay, so pixel shader works per pixel, and the vertex shader works per vertex of the model. And for all real-time rendering, we do a lot of things after the pixel shader, or during the pixel shader. It's like we use the post-process volume to have the exposure. We have the light shaft. They're all done at the very last stage. So this is the basic knowledge about this. I have changed name, but okay. Yeah. Some people say they changed name about previous tendency. No worry, it were all recorded there. So just I will know this you, and so I can add them together it means you attending class. Okay. So pixel shader and vertex shader. Yeah. And so now next we will start learning the OpenGL. But before that, I just want to share you something. It's like, if any of you would like to work in the games area or some film area, this area, yes, it can get a lot of money. Actually, if you check the salary package for some game company, it's really very high, and also the AAA film company, the salary is sky high, but it also requires a lot of things. I heard some guys. Let me find it. If I still have this, yeah. This is the software I heard from some guy who works in a AAA film company. What was that? The company is doing some film effect, visual effect for Marvelers and the DCs. So, for example, the character showed the Lost Player, the Eternity, a lot of Marvelous movies they made it. And so the guy told me they have to know all these things before they join the company. You see a lot of software, right? And those are things they learned, and usually they spend like 4 years to learn all these things. And each year they work from morning, 8 o'clock, he said, and until 12 o'clock in the midnight. And after 4 years, he learned all these things, and he can combine it and make some beautiful things. Now he works in a AAA film company, with a salary about more than a million Chinese RMB. So it can get a lot of money, but it means you need to know a lot of things, all these things. So it's not an easy step. Yeah, you can build very small games, not AAA games, but then it's limited because you can learn small part of things, but the final work may not look so dramatic. Okay, this is just something. And rather than building the game, if you want to build a better game, you also need to know how to optimize the game, right? So it's better you know some fundamental things. It's like you know how this work, how the graph is finally displayed on your machine. Once you know that, then you know, okay, from theoretically, I know, okay, this is part which might cause the bottleneck. Okay, I should focus on this, and then practice not, and then you will have it. Okay, so let's talk about OpenGL, and I will give you something. I will share you something, which I require you to work at home in the weekend to make it work. Yeah, I will turn on the WeChat. So in the WeChat, I just upload a file. It has the things about how to configure on the Windows PC or also the Mac. Either machine, if you use either of the machine, you should follow these steps. The one issue is I have this on the Visual Studio 2015. Some of you or most of you might use 17 or 19 now. If you're using 17, it's the same. It's almost the same. If you're using 19, it's slightly different. You can easily find how to change it, how to modify it a little bit on 19. The setting is the same, but the only difference is how you create a project. So all I ask is you to read this document. The software is Visual Studio. You need to download it. It's not cannot be shared. It's more than 10 gigabytes. It's quite a lot. So I think you just go to the Microsoft and then you can find it. And it also said how you can find these things. You use Google or Bing. Visual Studio, it's all there. Visual Studio setting, yeah. So if you're using the Mac, yeah, you need to have this basic setting and Xcode. You need to download the Xcode and install it. If you're using Windows, you should have the Visual Studio. You're a computer science major, so you should have Visual Studio, right? You should know the C++ or C before, because so each time you want to code something, you need to use the Visual Studio. So download the Visual Studio and do all this setting. I make it very clearly. So you Google Visual Studio and download it. You might need to register your name on this Microsoft as a student account and choose the right one for the free educational version. And then, yeah, Google this and download and Google GIFW. Yes, it can work on code blocks, but the thing is, you might need to see how to configure it on code block. Because I have some additional libraries, the GREW and GFW. This library, if you know how to import some library and make it work for a project, then it's okay. It works on code block. I mean, previously there's few students who prefer using code block, and if you know how to do the setting, yeah, it's work. It totally works. I mean, the coding part is exactly the same. The only different part is how you do this configuration. I mean, how you set things. And finally, when you finish that, about this part, there's a code from here. I do requires you to type everything, not copy and paste. Because if you copy and paste, there will be definitely some errors. Because in previous years, a lot of students just copy and paste, then they find some error. They cannot get anything. It reports some error. It's because when this is in PDF, right? So in PDF, if you copy and paste, some of this character might not be recognized. So it has some problem. Unless you just type it, you type it line by line, then you will see, okay, this is the problem. This is why it doesn't work. You should be able to have some fundamental things about the C++. If not, I do suggest you to learn something about C++ this weekend. Just find some video talks and video tutorial and spend at least 3 hours on it, and then you will know something. Okay, at least 3 hours on C++. If you don't know what these things mean, what are these the main and the structure, it's better you just spend 3 hours and see something of C++. Okay, so that's it for today, and we will learn the OpenGL things next week. Just please do read this. I mean, if you have problem, you can always use the internet. There are plenty of solutions on internet about how to set it, configure it. Just find it. Okay? Yeah. So that's it. Because you cannot learn everything during the course. We don't have that much time. And one more thing is like the final exam of this course. We will have some online exam which means when we have when we finally have the class in the classroom, maybe in 1 or 2 lectures, I will give you some work you need to code during the class, and maybe, for example, maybe I ask you to use OpenGL to draw satellites or something, and the satellite is rotating along the Earth. So if you can make it, you have higher score. If you cannot, you will have very low grade. So you know what's going on. Okay, so for this course, if you want to have a higher grade, do spend more time in coding and learn C++. Okay, so as I told you, you guys want to learn something more practical. Now I give you the chance to learn some practical coding, and now you spend more time on it, and I hope everything goes well. Okay, so that's it. Bye, and see you next time.